Hello, everyone. Thank you for watching. This is number 2, I guess it is, for my YouTube channel. We're going to be going over some of these scientific papers for quite a while. And today I thought I would do it live. Let's see what happens. So today we're going to be talking about nitrogen and potassium fertilizer ratios for turfgrass. We're going to be going over one paper and then an extension publication. So let's take a look at it. So if you're in the world of turfgrass, you may be familiar with Dr. George Snyder or Dr. John Cisar. If you aren't, I highly encourage you to do a Google Scholar search or a Turfgrass information file search on Snyder or Cisar, because George Snyder is great. He did a lot of really good work. He's retired now for a decade or more, but a lot of his work is highly influential for practitioners and in the world of research and science. It still has a great deal of value for us. So we're going to be going over this paper today. So what is the observation? So if we're going to walk through the scientific method, we're going to walk through this paper. What is the observation, or why is he even doing this research back 20 years ago? Why did he even do it? A lot of turf managers, in this particular paper is about golf, but I believe it's relevant to address some of the issues that exist in turfgrass industries beyond golf. So for example, lawn care or sod production, even sport turf. A lot of turf managers have the practice of applying a lot of potassium. You'll see fertilizer ratios, say a 15-0-15 or a 10-0-20 or 10-0-30s. They'll apply a lot of potassium for a variety of reasons that they believe are true. And one of those reasons is drought tolerance. Sometimes people do it because they think it provides a more healthy plant. I've seen a number of people talk about potassium as like the overall health element. Most of that is complete nonsense. There's very little evidence to support any of that. But that's why people apply a lot of it, because they've heard from somebody, or the salesman said something, or who knows where they got the information from. But they're convinced that applying potassium is going to help their turfgrass by reducing disease occurrence or drought issues, or it's going to help in some overall health turf benefit way. So they'll apply a lot of it. They'll apply a lot of potassium relative to nitrogen. And to be frank, I never have understood that. And I don't know George Snyder's mind. I'm not reading his mind, but I suspect he or Dr. Cisar may have thought the same thing. Why are these people doing this? There's not a lot of evidence to support that. So they went out in South Florida and decided to do a study to look at that, to see, is there indeed any benefit to applying greater amounts of potassium to nitrogen than, say, a 1-to-1 or something, or no potassium. What is the benefit to applying potassium, in South Florida on Bermudagrass, and increasing potassium relative to nitrogen on those systems. So this is the paper we're going to talk about. What I like to do is begin by reading the abstract. I've already gone through this. I've probably read this paper, I don't even know how many times. It's a really important paper. And I've highlighted some key points that I'm going to talk about today. So if you're new to this and you don't really know how to read a scientific article, or you don't think there's information in there, you can decipher it in a practical way. Hopefully we can get through it today and help you make sense of what is important to you if you're out applying fertilizer. So what I've highlighted here is the last couple of sentences of the abstract. And what it says is, however, increasing potassium fertilization beyond a K to N. Now, in this particular case, he's using the K to N ratio rather than an N to K, and I'll explain why that in a second. But it's no different. It's just inverted. A K to N fertilization ratio of a 0 to 5, which is a 2 to 1 N to K. Okay, so don't be confused. Fertilization of 0.5 to 1, which is a 2 to 1 N to K, had virtually no effect on turfgrass appearance, growth, on resistance to Bermudagrass decline, or on root weight. Increasing potassium relative to nitrogen fertilization did not provide commensurate increases in tissue K. So basically what this last sentence in the abstract is saying is that in this particular environment on Bermudagrass, and he used 328 here, Tiff Green 328. He applied a 2 to 1 nitrogen to potassium, and they saw a benefit. They applied a 1 to 1, and they saw virtually no further benefit for the quality. And they applied I think we can go through it. We're going to go through it. I think it was a 3 to 1 and a 4 to 1. So they kept applying more and more potassium, and they didn't see any more benefit than they did just applying a 2 to 1. They did see some increase in the tissue potassium, but the quality and the appearance and growth and resistance to Bermuda decline and root weight, none of that increased once you hit the 2 to 1 N to K ratio. So as a practitioner, you can just read this last sentence in the abstract, and especially if you're the owner or you're buying the fertilizer, and you can have some confidence in adjusting your fertilizer program to, let's say you're using a 15015 and it's costing whatever it is. You can change that to apply less potassium from a 15015 to say a 30015 or 20010 or something like that. It's going to cost you less money because you're applying less potassium, and you're basically going to have the same chance of seeing a turf quality result. You're not going to see any further benefit by applying this more potassium that you've been applying. So that's how you can use this last sentence in the abstract. So if you don't want anything else other than that, that's enough for you to go back to your business and look at your fertilizer program and ask yourself, am I actually as efficient as I could be with potassium? And there's a whole nother paper I'll talk about whether or not you should apply potassium at all. In this particular paper, they knew going in that the potassium in the soil was so low that there was a good chance of seeing a response to it. Okay, and they intentionally depleted the soil to the degree that they needed to see that response. But in other conditions where you're not dealing with sandy soils, or you're not dealing with high rainfall like in South Florida or whatever, you probably have enough potassium in your soil already. Okay, I wouldn't know that unless you took a soil test, but there's a good case to be made to eliminate potassium completely and really save a lot of money. But in this condition where it's low potassium in the soil, high sand, high rainfall, they found some benefit to applying only a 2 to 1, not anything further. So keep that in mind. You can just read this, and you can read this abstract for free on the internet. Just search the title, it'll pop up for free. You don't need to pay for the article. You can just get this abstract, and there's some good information just in the last sentence or two. But if you want to know more, you'll have to download it, go to the library, find a source that you can get this article, or join the ASA, the American Society of Agronomy, and you can download all these articles. Okay, so when you're going through the article, what we want to look at a couple things first as we get through here is that we want to kind of just get an idea of what he did. He's applying nitrogen. You can read through the materials and methods, which is the next section after the introduction. You can read through it and you can find out what he did. And he applied nitrogen as ammonium sulfate. He applied it at 2.5 and 10 grams of nitrogen beginning in February, and he fertilized near the middle of each month. So he fertilized monthly. And to convert this to English, just round numbers, this is a 0.5 pound of N per 1,000. This is 1 pound of N, and this is 2 pounds of N. So he's applying a lot of nitrogen at this very high rate. And this is a half a pound a month. 2.5 is a half a pound a month. So that'll give you an idea of what he did in terms of the amount of nitrogen. Then you go to the potassium, and they were the potassium source he used with potassium chloride. And this is critical because if you're really deep into the scientific literature and understanding the soil systems, potassium chloride was required, because if he had used potassium sulfate, we wouldn't know if any response was a result of the potassium or the sulfate unless he balanced out the sulfate, okay? Particularly in South Florida, where sulfate is low. So he used potassium chloride to not have to worry about that, because the response to chloride is essentially, it's never been documented. I've never seen a response. I've never seen anything in the literature about a turf responding to chloride. So so this was set up correctly, is basically what I'm saying, in terms of using the right potassium source. And then the nitrogen ratios that he used, you can go through here and find out how did he actually apply the N to K. And the K to N ratios of 0, so he's applying no potassium, okay? He's applying half the potassium to nitrogen, the equal amounts of nitrogen, potassium, and then twice the amount of potassium to nitrogen. So he's doing his K to N, and he actually explains this here. He used K to N rather than N to K because you can't divide anything by 0. So if he had done a 0 or the no K treatment, it would have produced an undefined N to K ratio. So it's just a mathematical thing where you can't divide by 0, so you wouldn't have been able to do it. So he just divided 0 by 1, and he comes up with 0. So anyway, K to N, that's the reason he did it. But that's how you convert it back. Just N to K's, or it's a 0, basically nitrogen, and then half the nitrogen as potassium, equal amounts of N and K, and then double the potassium as nitrogen is how he applied it. So you can scan back through here if you want any more further information about how he actually did the study. He applied micronutrients. It shows you how he did the ratings. You'll want to know, because he's going to show some soil. You'll want to know the soil extractant he used. He used Malic 1. And the soil levels of potassium that he started with are right here in table 2. So he started with 10 parts per million Malic 1 potassium, which is on this particular soil, because they've actually done a correlation between Malic 1 and Malic 3. It's somewhere between 10 and 15 Malic 3. So it is quite low in potassium. And then they got a response on this particular soil. So keep that in mind if you're in a different situation where you have a different soil. If your soil potassium is 10 or 15 parts per million, this is documentation that turfgrass may respond to applied potassium when the Malic, in this case Malic 1, but Malic 3 is 10 to 15. There's a good chance you're going to see a response to applied potassium. The question is, at what point will you not see a response? And that's for another video, but it's probably somewhere around 30 or 40, something like that. And I'll go into that in the future. But keep in mind, he used Malic 1. So that's the materials and methods. Real quick, for those people, occasionally I get this question, and I don't really know why. When I talk about like pH reduction using either elemental sulfur or ammonium sulfate, I just got this question like 4 or 5 months ago down in South Florida, where I said, well, if your pH is 7 or 7.5 or 8 or whatever the number is in that range, and you're looking to reduce that pH down, which I would argue we need more information to figure out whether or not you actually need to reduce it. But let's say you felt like you needed to reduce it. I was saying just switch your nitrogen source from urea to ammonium sulfate. And I don't know why people think that doesn't work, but I get a lot of questions like, well, how long is that going to take? And how do you know that actually works? And all these things. And like, you're applying hydrogen ions directly to the soil in the form of ammonium. You're going to reduce the soil pH. And there's I don't know how many documentation publications there are on that topic, but here's one here, table 1. So when you're applying a half a pound of N as ammonium sulfate, they started at 6.9 on the pH, and it went to 7.2 the next year. The next year it's 6.1. And so this is 3 years later, it's 5.8. So he dropped it a full point in 3 years just by switching or just by using ammonium sulfate at a half a pound. Okay. So in South Florida, that's a reasonable rate for this grass. It's 6 pounds a year. It's probably on the little high end now that we've done some more calibrations, but it's reasonable. And you can see how low you can reduce it at these really high rates where you're applying 2 pounds a month. I mean, you can lower it down below 5. Started at 7 basically, and now you're down below 5 in 2 or 3 years. So this is just a side benefit of this paper, is that they published the reduction in soil pH as a result of applying ammonium sulfate as their nitrogen source. So you can very easily reduce the pH using ammonium sulfate. You just have to have patience with time, and you just use it regularly as your nitrogen source. You don't have to go out and buy and apply a unique application of just elemental sulfur if you don't desire to do that, if you have the patience to wait a year or two. So anyway, just a side benefit of this paper. Okay, so when we get to the results and discussion, there's a couple of points that I wanted to point out here. Okay, so table 3. This is the influence of the nitrogen and potassium ratios on turf quality. Okay, now it might not necessarily be as easy to interpret as you might want, but I'll walk you through this. So when you're reading these tables like this, you're going to see a lot of numbers and a lot of symbols and things like this. If you're not used to that, the way to read this is underneath this independent line. So this is what's referred to as a independent line. So this is a new variable, nitrogen variable, NK variable, NK interaction. These are all different variables. So within this column, this 1990 Q2 column underneath K to N ratios, we have all the various treatments, 0.5 and so forth. And we'll see at the beginning, there was a significant difference. So when it says sig, they say sig, what this means is significant difference. And this isn't they did these by quarters. So they pulled the data by quarters. And what this means is, yes, there was a difference. If this was NS, in fact, maybe there isn't. Yeah. So here's an NS down here at the bottom. Right here, there's a couple of NSs. Okay, that would mean that there were no differences among the compared means or the compared treatments. All right. In this case, it says there was a difference. All right. If you see 2 stars or 1 star, the more stars there are, I think now they've actually adjusted that, but the more stars there are, the more significant it is. You can read that down here. In other words, the less likely I'm going to be wrong when I say there was a difference. That's technically how to say it. But basically, the more confidence we have that there actually was a difference between the means is what this means when you have more stars. So when you see the LSD 0.05, this is the least significant difference. So 0.05 at the 5% confidence level. So 0.2 is the least significant difference. So you can go through here and say, okay, 6.6 and 6.6 are, the difference between these is less than 0.2, so they're the same. The difference between these two, 6.2 and 6.6, is greater than 0.2, so they're different. So that's how you would use the statistics in that table. So now that we know how to read the table and we know how to walk through it, it's still the benefit, in my opinion, the benefit of this table, or the gravity of this table, is not as easily viewed in data form as it is in graph form. Okay, so what I've done over the years is I have taken these data and converted them into a graph, because I think that's more useful. And so I did that and turned it into an extension publication. And this table, actually this graph here on the right, is that table. So if you look, turf quality is on the y-axis, and then you have various seasons on the x-axis, and here's all the ratios. You'll see it begins at between 6 and 6.5. And if you come over here, it's like 6.2 and 6.6. So these are the same numbers in this Q290 column as exists right here. And then at the end, you'll see all the numbers are right below 7. And then the essentially the control is, it looks like it's right above 5. And you'll see that here. Yeah, so 6.9, 6.96. It's right about 7. And then the control is 5.1. So this is the graphic form of that data table. And you can see now much more clearly the influence of these treatments, where the blue line here is where you're applying no potassium at all. Okay, so it's a 1 to 0 in decay. So in the case where you have soil Mehlich 1 potassium of 10 or around 10 or less, there is a decent probability that you're going to see a turfgrass response, because here's what happens if it's 10 and you don't put any nitrogen or don't put any potassium down. And then the 2 to 1, you'll see an increase in quality. So this is turfgrass quality. You'll see an increase in turfgrass quality. But here's the key to that table, is that you apply more potassium, a 1 to 1. You apply even more potassium, a 1 to 2. You don't see the green line and the purple line continue to increase. You see the increase in cases where the soil is deficient or the turfgrass is deficient. You see an increase by applying a 2 to 1 with the quality. But you don't see any more increase by continuing to apply more. Okay, that's what this table is saying. And when you read these things or you see these things in data format, it might not necessarily be the format that really speaks to you. You might be a visual person and you want to see it in a graph form. Well, it might take a little time to put these numbers in a graph, but I just copy and paste them into Excel and do a little bit of work, maybe 1 or 2 minutes, and you can see, oh, that's what happens. All these lines are essentially the same, but greater than if you didn't apply anything. So we should apply a 2 to 1. Well, why can't I apply 1 to 2? You can. You're just wasting your money. Okay, that's what this is saying. So that's the one of the greatest conclusions of this paper is this table right here. Okay, so as we continue to go through here, we'll get to the potassium content. So the tissue K. So you'll see essentially it looks like the same table, but instead of quality, you'll see tissue K, and it's in grams per kilogram. Okay, so unfortunately, this isn't common knowledge to convert grams to kilogram to percentage. Usually people are more familiar with like what parts per million or percentage, not necessarily parts per thousand, which is what grams per kilogram are. So to convert grams per kilogram to percentage, which would be a little bit easier to communicate and to talk about, you just move a decimal over 1 point. So grams to kilogram to percentage, you just move it over 1 point. So this is 1.2% potassium in the tissue, and the high ratio is 2%. Okay, that's the way you would convert that. I guess you just have to know that, but it's grams per kilogram, and you don't always see this particular unit, but anyway. So I converted this too. These are all like numbers. You're like, oh, there's a lot. All these are different from every single time level. There's a difference, but it doesn't really speak to me. So I just converted that to this graph. Okay, and now you can see the magnitude of that table, the importance of that table, and that is, if you don't apply any potassium on a turfgrass that is deficient, in this case it was deficient at Mehlich 1 of 10, you will likely have a reduction in potassium in the leaf tissue. Okay, this is clear in this case. But to increase the leaf tissue potassium up to I wouldn't say maximum, but up to a very high level, again, you don't need to apply all these high levels of potassium, 1 to 2s and 1 to 1s. Okay. The 2 to 1 will do it. Now, statistically, they showed that a 1 to 1 would be the statistical maximum. There's no difference between a 1 to 1 and a 1 to 2. So like a 15:0:15, if you change that to a 15:0:30, then that would be unnecessary. It'd be wasteful. But they did show in some instances going from a 1 to 2, a 1 to 1, a 2 to 1 in decay to a 1 to 1 in decay, it can increase leaf tissue potassium. Now, I wouldn't get caught up in this because leaf tissue analysis is many levels separated from soil testing, and even soil testing is not that good in turfgrass. Okay, it's not. We'll go into that for sure in a future video, but there are great pitfalls that people fall victim to by using soil tests in turfgrass. Now take that many levels separated and exponentially more problems with tissue. However, having said that, for scientists, leaf tissue analysis, it can be quite useful. I just don't think that we've done enough work to actually take those numbers and move it into the realm of practitioners to the point that I'm confident in saying your leaf tissue potassium should be this or it should be that. There's a lot of variability. So having said that, don't put too much weight in this necessarily in terms of the usage of tissue analysis. Just understand that the leaf tissue potassium also increases with using a 2 to 1, but additional inputs of potassium, certainly above a 1 to 1, are wasteful. You're not going to have a 2% potassium in the leaf tissue using a 1 to 1. And now you put in a 1 to 2, and all of a sudden your leaf tissue potassium is 3%, or 4% or whatever. I mean, you're not going to continue to increase the potassium to a concomitant level when you're increasing, the potassium that you're applying. So keep that in mind. Okay. So you can go through here, keep going through here, but at the end here, we have a couple highlighted sentences that we want to use in closing here. Okay. So the thatch and roots. I for some reason early on after I graduated grad school, I ran into a business owner who said, I'm applying all this potassium to increase my roots. I'm like, well, why are you doing that? And well, that's what you guys told me to do. And I'm like, well, I didn't tell you to do that. I don't know where you got that from, but this whole idea of like below ground growth, I'm going to apply all this potassium and it's going to increase my health going into winter, and it's going to increase this resistance to this. A lot of that is just marketing and smoke and mirrors. If the turfgrass has enough potassium, meaning, it's a fairly normal situation with, normal levels of potassium, meaning, above 40, 50 parts per million, maybe like 3, applying more isn't really you're not going to see much benefit to that. So anyway, so in the last part of this document, we see the sentence. However, when K was applied in any of the 3 K to N ratios studied, so meaning any potassium was applied at all, there were no differences in root weights among ratios. Okay. So there are documents where you'll see some publications where you'll find some small differences between root weights, and that they exist. But this is a document showing that when K was applied, okay, so from a 2 to 1 in decay, a 1 to 1 in decay, and a 1 to 2 in decay. So between those, there was no difference, meaning that when it was deficient, when no potassium was applied, they applied 2 to 1, they saw that difference. But when they kept applying more, there were no differences. Okay. So please have some confidence in the management practice of applying a 2-to-1 will get you what you're gonna get out of it, whatever you're gonna get out of it, if anything. Which I would, there's a good evidence to just eliminate all potassium. But if you're gonna get something out of potassium, it's going to be in cases where the soil's low in potassium, and just applying a 2-to-1 a little bit is going to get you whatever response you're going to get. Okay. Don't think you're going to have an extra warmth under 2 or 3 blankets, because 2 or 3 levels of potassium, you're going to be extra potassium. No, you're not. You're going to get whatever you're going to get using a 2-to-1, according to this paper. Okay. And I'm going to go over, there's 2 more papers that I will go over at some point that show the same thing. Okay. Those papers didn't have the 2-to-1. They started at a 1-to-1, but continuing to apply more didn't show any benefit. Okay. So a range of soil pH, soil K, clipping height, and disease pressure occurred during the third year of the study. Nevertheless, even across this range of conditions, increasing potassium beyond a potassium N ratio of 0:5 to 1, which is a 2-to-1 into K, had virtually no effect on turfgrass appearance, growth, resistance to Bermudagrass decline, thatch depth, or root weight. Okay. So they concluded after, I guess it's, 2 years of studying, I guess they had a break there. I don't know why there's a separation there, but 2 or 3 years of studying in South Florida, looking at soils, looking at tissue weights, looking at quality, looking at tissue K. I mean, all these things, that applying a fertilizer of just 1 part nitrogen and a 1/2 part potassium got them virtually all the beneficial responses that they were going to get out of the potassium. Okay. We're going to go over another paper in the future where it ends up being a 1-to-1. But that's for a future discussion. But certainly nothing greater than a 1-to-1 is ever likely going to be beneficial to you. Okay. So this is how you can use the data in this paper. You can go out, you can reduce your potassium down to about a 2-to-1 into K. Make sure that you're not paying the same amount for the fertilizer. Make sure that, you're getting either a reduction in the bag of fertilizer, or you're adjusting the nitrogen ratio, right? Nitrogen amount up. So you end up buying fewer bags of fertilizer. One way or the other, you need to make sure that you're saving yourself money, because potassium is not an element of environmental impairment. There's not a lot of environmental concern with potassium. It's an economic concern. Okay. So please consider that when it comes to developing a more efficient program. Okay, that's all we got today. I appreciate you watching. I hope you found it beneficial. If you did or you did not, please leave a note in the comments. I would definitely like to know your input. If I am providing the content or that you like or don't like, let me know. I certainly look forward to hearing from you. Appreciate everybody. See you next time.